Happy morning, my dear student friends. I am Dr. A. Lakshmana, Associate Professor of Mathematics. Today we are going to discuss about an important concepts, applications of Lagrange's mean value theorems, which are very useful to Andhra Pradesh Telangana set, UGC JRF and degree college lecturers, and also particularly second BSc Mathematics, right? So topic is differentiation. So today lecture is applications of Lagrange's mean value theorem. So coming to the question number 1. Let f of x is equal to 1 plus x square for all x belongs to closed interval 1, 2. So 1 plus x square is a polynomial function which is always continuous and variable. So therefore, immediately by applying a Lagrange's theorem, so what is Lagrange's theorem? Immediately there exists C in the open interval AB. AB such that f dash C is equal to, formula is f of b minus f of a by b minus a. Here a replaced here because this symbol is such that only, right? So here a is equal to 1, b is equal to 2 is already given in the problem. So closed interval 1, 2. So just replace it. So first of all f of b minus f of a. So f of 2, what is the value of f of 2? You put the value, f of x means 1 plus x square. So 1 plus 2 square is nothing but 5. What about f of 1? 1 plus 1 square is nothing but 2. So therefore f of 2 minus f of 1 by 2 minus 1 is equal to f of 2 already 5 minus 2 by 2 minus 1 is 1 is nothing but 3 only. What about f dash? F dash c. First of all, immediately you can find f dash of x. Already f of x is nothing but 1 plus x square. 1 plus x square derivative is 1 derivative is 1 0. X derivative is 2x. That is 2x only. So therefore f dash c is equal to this value. F dash is this value means how much here? Already we are getting a 3. This is 3 only. So you put the value 2c is equal to 3. That implies c is equal to 3 by 2. So 3 by 2 is nothing but 1.5. So nothing but it belongs to 1, 2. It is simple technique only. So by computative model, immediately you can find a derivative. First of all, you check whether it is continuous and derivable or not on this interval. If both exist, immediately c belongs to open interval AB, such that this is the formula f dash c is equal to f of b minus f of a by b minus a. Just a replaces 1 and b replaces 2. You put the value and its derivative f dash x means 1 derivative 0, x derivative is 2a, x square derivative is 2x. So just x replaces only c. So f2c is equal to 3. Already because of f of b minus f of a b minus a is nothing but 3 only. So you get the ultimate value c is equal to 3 by 2 is the final value of the first problem. The second one, f of x is x cube. So x cube is also polynomial function which is always continuous and variable. Immediately there exists a Lagrange's mean value theorem. Right? So immediately, there exists a c in open interval AB such that f dash c is equal to f of b minus f of a by b minus. This is standard formula, right? By using the Lagrange's mean value theorem. Immediately, what is here? A is equal to minus 1, b is equal to 1 only. You put the value, immediately you can find the whole value. So f of b minus, that is f of 1 minus f of minus 1 by b minus 1 is 2 is equal to, what is f of 1? 1 cube minus 1 whole cube by b minus is 2 only. So this is what the value is. It is a 1 cube is 1 minus 1 whole cube minus 1 cube minus 1 plus 1. This final value is 1. So therefore, what about f dash x? F dash x means x square. Here f of x is x cube. This is 3x square, right? So f dash c is equal to this value, nothing but 1. That implies 3c square is equal to 1. Implies c square is equal to 1 by 3. Implies c is equal to plus or minus 1 by root 3. So here our interval is this one only. So minus 1 and plus 1. Therefore ultimately what is C value? C is equal to plus or minus 1 by root 3. This belongs to minus 1 comma 1 is our solution of the problem number 2. The second one, f of x, third one is f of x is equal to x into x minus 1, x minus 2 for all x belongs to 0 comma 1 by 2. 0 comma 1 by 2 is also this. First of all you can multiply this one. So x square minus 3x plus 2. Ultimately x cube minus 3x square plus 2x is the final value. So f of x is equal to x into x minus 1, x minus 2 for all x belongs to 0 comma 1 by 2 is given. So just you can multiply this, we get this one only, right? So this is also polynomial function which is continuous and variable. Therefore by applying a Lagrange's mean value theorem, by Lagrange's mean value theorem, there exists C in open interval AB such that f dash C is equal to f of b minus f of a by b minus a. So nothing but f of b means f of half minus f of 0 by half minus 0, right? So first of all you can find f of half. What is the value of f of half? You put the value here in this case or here, no problem. Here put this one, half into half minus 1, half minus 2, right? So half into half minus 1 minus half, this is minus 3 by 2. So ultimately this is 3 by 8 because of minus minus plus 3 by 8 is the value. What about f of 0? F of 0, 0 into is getting 0 into 0 minus 1, 0 minus 2. 0 into this one, 0 only, right? What about f dash x? F dash x is equal to, you can find this value. So 3x square minus 6x plus 2 only. But f dash c is equal to, what is the final value? What is f of this? F dash c 3c square minus 6c plus 2 only. This is f dash c value. So f dash c is equal to, what is the value? F of b minus f of a, b minus a. F of b minus f of a is equal, f dash c is equal to f of b minus f of a by b minus a. So ultimately 3c square minus 6c plus 2 is equal to, what is this value? This value is half times of that 3 by 8 minus 0 by half. So that is 3 by 4. This reciprocal is, so what is the reciprocal? 3 by 8 into 2 by 1. So it is 4 times cancelled and finally this is 3 by 4. Finally 3 by 4. So 3c square minus 6c plus 2 is equal to 3 by 4. So implies 3c square minus 6. 3c square minus 6c plus 2, left hand right hand taken as left is 3 by 4 only. So it is what is this one? This is 8 minus 3, 5 by 8. So 3c square minus 6c plus 5 by 4 is equal to 0. So it is a quadratic equation only. So not getting roots directly. So formula is, so already you know the formula, x is equal to minus b plus r minus b square minus 4ac under root by 2a. This is the formula. Then the roots are exist, ax square plus bx plus c. Ax square plus bx plus c is equal to 0. So what are the roots? Minus b plus m root or b square minus 4ac by 2a. So this is, therefore applying this one, c is equal to minus b means 6 plus r minus 6 square means 36 minus 4 into a means 3, c means 5 by 4 under root by 2 into 3, that is 6 plus r minus 36, this 4 cancel only, so is nothing but minus 15 under root by 6. This is 6 plus r minus, so 36 minus 15, 21, root 21 by 6. So what is our value? So our interval is, original interval c belongs to 0 comma 1 by 2. 0 comma 1 by 2 is an interval is there. It's an open interval, not closed interval. It's an open interval only. Therefore, but the C6 plus or minus root 21 by 6. There are two values only, 6 plus root 21 by 6 and 6 minus root 21 by 6. 6 plus root 21 by 6 is more than 1. Therefore, only 6 minus root 21 by 2. Therefore, ultimate our value is equal to C is equal to 6 minus root 21 by 6 is the final value of our problem only. So these are the applications of the applications of Lagrange's mean value theorem. Thank you one and all.